Welcome to NET JRF Scholars YouTube channel. In the previous video, we have looked at the levels of teaching. Today, in this video, we are going to look at the number system. This is not the number system that we do in mathematical aptitude. It is a number system that comes under the information and communication technology. As part of this lecture, we are going to look at the two main types of number systems, that is non-positional and positional number systems. And we have four multiple types in the positional number system. They are decimal, binary, octal, and hexadecimal. So we'll first try to understand non-positional, positional, and then we will look at decimal, binary, octal, hexadecimal. I have made the slides as you can directly copy into your notes, so it's easy for you to revise before the examination. So I have given very precisely in the slides, so just copy as it is helpful for you to revise. First, we will try to understand what is positional and the non-positional number system. So, non-positional number system. Here, each symbol represents the same value regardless of position. It means that, so the symbol here are the lines. Okay. Here, when I wrote 1, it is 1. When I wrote 2, it is 2. When I wrote 3, it is 3. When I wrote 4, it means 4. Okay. The every symbol has the value of 1. Value is equal to 1, irrespective of its position. Okay. This we can mostly see in the competitions of the villages, where let's say there is a competition of who can eat the more chapatis, okay, in a hotel. If he eat 150 chapatis, he will get a prize. At a time, they do not count as 1, 2, 3, 4. Instead, they mark each chapati as lines. Okay, so the system that they use is known as non-positional number system. Next, we have positional number system. Here, use only a symbols called digits. So here, symbols are called as digits in the positional number system. These symbols represents different values depending on its position occupy in a number. Let's say I have said 24. It does not mean 2 and 4, right? It means 2 tens plus 4 ones. So it means 20 plus 4 is 24. So if you say 42, this value is 24, and this becomes 4 into 10 plus 2 into 1, then 40 plus 2 is 42, right? So if it is a non-positional number, the value of both should be 6 only. But being it's a positional, 42 and 24 has two different values, and 42 has the higher value, 24 is lower. So there are 4 such type of positional number systems. They are decimal, what we have just looked is the decimal number system, binary, octal, and hexadecimal. So base is the total number of digits in the number system. As in the decimal number system, we have digits from 0 to 9. Total is 10 digits. So the base value for the decimal number system is 10. The maximum value of a single digit is always equal to 1 less than the value of the base. For the decimal numbers, the maximum value, what it is saying, 1 less than the base. So here base is 10 and 1 less, so we are doing minus from the 10. So the maximum value of a decimal number system is 9. As we can see, it starts from 0 and still 9. So 9 is the maximum value. Now we will look one by one positional number system types. First we will start with the decimal. So decimal number system. This number system has the symbols from 0 to 9. It means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Its base value 10. It means here total there are 10 numbers. So the base value is the total symbols in the number system. Next we have maximum value of a single digit. As I have explained just now, the maximum value is 9 for the decimal number system. So this is the system that we use in our daily life. So here as you can see 2586. So the value of each number in each position is different. Here 2 at the position of 1000, so 2 into 1000, plus 5 at the position of hundreds, 5 into 100, and 8 in the position of tens, okay, and 6 in the position of ones. So we convert it as 2 into 10 to the power of 3 plus 5 into 10 to the power of 2 plus 8 into 10 to the power of 1 plus 6 into 10 to the power of 0. 8 to the power of 0 is equal to 1, right? So anything power of 0 is 1. So 6 into 1. So we can write 1 as 10 to the power of 0. So that's what you can see here. Okay. Next we have binary number system. Here in this system we can only see the two numbers, that is 0 and 1, and hence the base is only 2. The maximum value of a single digit here is 1 because we have only 2, out of which 1 is higher, and this is what used in the computers. That's why these are famous for computer science students, and everything that is stored in the systems are converted into zeros and ones. So here you can see the binary is converted into a decimal. Okay, binary means 2 and the decimal is 10. This representing the base value, something that is in the bracket after the number. If you see here 10, it is decimal. If you see here 8, it is octal. If you see 2, it is binary. If you 2 16, then it is hexadecimal. Okay, so in the text after the bracket in the subscript represent the base of the number system. And here, rather than the concepts, in the UGC NET examination, they asked about the conversion from the one number system to the another number system. So we will look at the conversion first from the binary to decimal and then decimal to binary, because these two conversions are very, very important and they're repeatedly asking in the UGC NET examination paper 1. Okay, first we will look at the decimal to binary. So how can we convert from the decimal to binary? Let's say there is 36. Now we will try to convert and find the value in the binary. So we all know we have to do an LCM with the 2. Why we have to do LCM with the 2? Because we are converting into binary number. So we need to take the base value of the binary number. Okay. So 2, 18 the 36, you are left with the remainder 0. Next 2, 9 the 18 and you are left with 0. Then 2, 4 the 8 and the remainder is 1. 2, 2 the 4 and the remainder is 1. Next 2, 1 the 2 and the remainder is 0. So you have to follow this way to write the binary number. So the binary equivalent of 36 decimal is equal to, from this first 1, next this 0, next 0, next 1, next 0, next 0, and 2. So the binary value of 36 in decimal is 100,100. That's it. So we have to go from the down to up, below to above. So 100,100. So as we converted into base, so as converted into binary, so we have to give the base value of the binary system, that is 2. Okay. Now we will try to convert the binary into decimal. So how we can convert that? Now we need to count. We have 5 digits in total. So we have to start from the right side. So 1 into 10 to the power 1 into 2 to the power, as it is in the already it is in the binary, right? So we need to do 1 into 2 to the power of 0 plus 0 into 2 to the power of 1. Okay, next we have 1, right? So 1 into 2 to the power of 2. Next we have 0, that is 0 into 2 to the power of 3. Next we have 1 into 2 to the power of 4. Okay, now 1 into 2 to the power of 4 is 16. Okay, 0 into something 0, and 1 into 2 to the power of 4 is 1 into 4, 0 into 2 to the power of 0, and 1 into a power 0 is equal to 1, so 1 into 1, 1. So 16 plus 4 plus 1. So the value is 21 in the decimal. So this is how we can convert from the binary to decimal. We have to start from the right, and we need to assign the powers. First, for the 1 it is 2 power 0, and next 2 power 1, 2 power 2, 2 power 3, and 2 power 4. In simply we can also do him as a shortcut, I will tell you. So just remove the zeros, right? Then you say 2 to the power of 0, then 1 is left, 2 to the power of 2, and 3 goes here, 2 to the power of 4. So 16, 4, 1. So that is 21. So you can do it as, it is simple because the values of the zeros left get 0, right? So you have to take only the ones. Okay, but you need to be careful, okay, while following this shortcut. Now we are looking the same conversion but with a decimal point here, as you can clearly see. Why it is important? Because in easy papers they might ask without a decimal or a float point, but when a paper, especially for the papers such as where many candidates appear for the examination, such as pol science, economy, commerce, they always ask the odd questions. Okay, so that's why it's important to learn the conversion with the decimals as well. As you can see here, first the conversion here is the number is in the decimal, right? And but we have 3 numbers after the point, so we need to multiple 2 to the power of 3. Here 2 representing the conversion as we are converting into the binary, and the 3 representing the number of digits after the decimal points. So if we calculate 67.225 into 8, we will get 541. Okay, once getting the 541, we need to now convert into using same method as we have seen, because now there is no decimal point, right? Okay, now we can convert. So 2 2s are 1 remain, 2 7s are 1 remain, 0, 2 5s are 10, right? 0, we are left with 1, so 270, so the remainder is 1. Next 2 1s are, and next we have 7, 3 is a, we left with 1, that is 5, the remainder is 0. Next 2, 2 6 are 12, 2 7 are 14, so we get the remainder as 1. Next 2 3 is 6, 2 3 is 6, we'll get the remainder 1. Next 2 1s are 2, 2 6 are 12, we'll get the remainder 1. Okay, I'll take. Okay, next 2 8s are, we'll get the remainder 0. Okay, next 2 4s are, we'll get the remainder 0. Next 2 2s are, we'll get the remainder 0. Next 2 1s are, we'll get the remainder 0. So we have find out the first we have converted decimal into the decimal number into a proper number, and this proper number is converting into the binary. Okay, and now we need to first the binary number that we get for 541, not for the 67.625. So first we have to write the binary number for 541, that is we have to go this way, right? So we will start writing 1, this one. Next we have 0, this 0. Okay, I'll change the color of the pen here. Okay, we have covered 1 0. Okay, 1 0 is over. Next we have 0. Next we have 0, and next we have 0, and next we have 1 1 1. So 1 1 1. Next we have 0 1 0 1. So the value we get here is the binary number for 541, not for the 67.225. So then we need to add point, right? So here you can see after the 3 we have 3 digits after the decimal point, so we need to keep the point after the 3 numbers, that is 1 2 3. So this is the binary. So the binary value of 67.2625 is 1000011.101. This is the binary value of 67.625. Now we will convert this decimal binary into the decimal number system. Okay, so it is the same way, there is not much difference in this case, but there is a small difference at the end. As I said, first we need to start from the right side. So 1 into 2 to the power of 0 plus 0 into 2 to the power of 1 plus 1 into 2 to the power of 2 plus 0 into 2 to the power of 3 plus 0 into 2 to the power of 4 plus 2 zeros are covered, 1 into 2 to the power of 5 plus 1 into 2 to the power of 6. Now we will cancel the 0 terms because we will get the 0, right? So we will look 1 into 2 to the power of 2 to the power of 6, right? So 2 into 2 into 2 into 2 into 2 into 2. So 8 into 8, that is 8 8 is 64. So 64 plus 32, 4 and 1. So the total value is 101. Okay, so this is the decimal, right, for this number, but we have two digits after the point. As a result, we need to divide 101 by 2 to the power 2. Okay, 2 to the power of 2. 2 is the base of the binary number, and we have 2 digits, right? So we have that power. So 101 2 to the power of 2, that is 25.25. So the decimal number for this binary number is, I'll change the color here, 25.25. You can learn this method. It is very important, especially for the subjects such as English, commerce, economics, political science, history, etc. And we will look at the two other number systems. Okay. Before that, we'll change the pen of the color. So we have covered the two number systems, that is binary and the decimal. Now we will look at the octodecimal. Has the symbols from 0 to 7. 0, 1, 2, 3, 4, 5, 6 and 7. Hence its base value is 8, as there are total 8. So the maximum value of single digit is 7. So 3 bits, that is 2 to the power of 3 is equal to 8, right, are sufficient to represent the any octal number in binary. It means that, as you can see, the base value is 8, right? So we need 3 bits, okay, to represent the any digit from this octal number system, that is 0 to 7, not more than this. So now we will try converting 2057. So it's in the octo number, right? It should be 8. So we will try to convert this number. So the same way, we have now what we are doing, we are converting it into the decimal. Okay, it is better always convert into the decimal first and then the given or asked number system. Okay, I'll give you how to do the how to convert from the one number system to another number system, because we have 4 different types and they can ask in 16 different ways regarding the conversion. So that I will give a one-stop solution for all the 16 types of conversions. Don't worry about it. First we will look at this conversion of this octal number into the decimal number. So we have to start from the right side, that is 7 into 10 to the power of 0, as we are converting into the decimal, 10 to the power of 1, 0 into 10 to the power of 2, 2 into 10 to the power of 3. So here the value is here a small correction, that is we have to give, as you can see here, as we are converting into binary to decimal, we have taken 10. Okay, here in this case, while we are converting, this is an octal, right? We need to convert into decimal. So we have to first solve that in the octal. That is, I will clear here for the first, then I will try to explain again. Okay, do not confuse. Okay, I have confused here, but I'll make it clear. Give me a minute. Let me clear. Okay, so here the base value is 8, right? So we need to take the account the base value. So 2057, the base value is 8. So we have to do the conversion. We have to start from the right side. That is 7 into 8 to the power of 0 plus 5 into 8 to the power of 1 plus 0 into 8 to the power of 2 plus 2 into 8 to the power of 3. So the value of 2 into 8 to the power of 3 is 1024, and it means 0, and 8 into 5 into 8 to the power of 1, that is 5 into 8 is nothing but 40, and 7 into 1, that is 7. So 1024 plus 40 plus 7 is equal to 1071. So this is in the decimal. So the decimal number for 2057 octal is 1071. Okay. Next we have hexadecimal. That is, we have the symbols from 0 to 9, 0 to 9 and A to F. These A to F are nothing but 10 to 15. Okay. 10 represents A, B represents 11, C represents 12, D represents 13, E represents 14, F represents 15. So the maximum value of single digit is 15. As you can see, that is nothing but F. Okay. So as the total number in this system are 16, so 2 to the power of 4. So it means 4 bits are sufficient to represent any hexadecimal digit, because in total there are only 16 and 2 power 4 is equal to 16. Now we will try to convert this hexadecimal into the decimal. So we have to start from the right. So F into, that is 16 to the power of 0, and A into 16 to the power of 1 plus 1 into 16 to the power of 2. So we have 256. Here A means 10. So 10 into 16 power of 1, it means 10 into 16, that is 160. And F means 15. 15 into anything power of 0 is 1, so 15. So 256 plus 160 plus 15. So the value is 437. So it is the decimal. So I have discussed here, as you can able to convert any number that is given in binary, octal or hexadecimal into the decimal. So once you learn this, if they ask any conversion, it's easy for you. I will tell how you have to solve such problems. So they might ask about you 16 types. Okay, let's say binary to decimal, binary to octal, binary to hexadecimal, then decimal to binary, okay, decimal to octal, decimal to hexadecimal, next octal to binary, octal to hexadecimal, octal to decimal. Next we have hexadecimal to binary, hexadecimal to octal, hexadecimal to decimal. So they can ask you in the 12 types, but I will provide you a single solution for all these 12 types of conversion. Okay, that is given number system. Let's say they have given you in the binary number system, whatever they have given, then you need to convert into the decimal number system. Once converting the decimal number system, it's easy for you to convert the given or asked number system, right? Asked number system. So whatever they'll ask, you need to first convert that into the binary number system. So that's the decimal number system. That's why I have shown you conversion any number system into the decimal number system, and any decimal number system into the remaining number systems. So then it's become easy for you solve all the 12 types by mediating with the decimal number system. Otherwise it's literally confusing if you want to convert binary directly into hexadecimal. So it's better to use the decimal number system in between. Okay, in the next video I'm going to discuss about the basics in logical reasoning unit. Okay, and following one more video on the ICT. So please subscribe to our channel NET JRF Scholars for more interesting videos for UGC NET Paper 1, and the slides we provide is really helpful as you can make notes out of it. Please take notes, as you cannot watch the videos again and again, and the notes will be helpful for you to revise before the examination. You have to revise for 1 month at least. So it's better if you have the notes. Thank you Please subscribe to our channel NET JRF Scholars.